Thank you, Piero, and thank you all for coming. It's such a great pleasure to be here at Laser and to share a stage with such wonderful and distinguished speakers. So, two psychologists, an artist, and a mathematician walk into a bar, right? What is mathematician going to do? He is the cerebral one, right? Who is going to show you some formulas and equations. I was thinking about going down that road for a few seconds, but then I thought perhaps I should talk about something else. And well, I want to tell you a story to kind of set the stage. I read this article recently, and it really resonated with me, and since that time I have been telling about this to everyone, and so I want to share it with you. It's an article, and here is a laser. It's an article in Scientific American, which is a magazine about science. And it's written by a scientist who shares his experience, a very special experience. And he says, I just witnessed an event so mysterious that it shook my skepticism. And he says that in the past, when people asked him whether he encountered something mysterious, mystical, he always said, no, never happened. But now, he says, my answer is yes, now I have. And just to give you short of the story, is that he says he got married. He got married last summer, in June. And his wife, his bride, came from Germany, and she moved to live with him a couple of weeks before the wedding. And she brought with her a lot of stuff from Germany. And one of the things that she brought was a radio, was an old radio from her grandfather. She was very close to her grandfather, but the grandfather passed away when she was 16. And she was hoping that her future husband, because he's a scientist, will be able to fix it. So he opened it up and he tried to make a connection. He said, yeah, I even tried the old-fashioned way of smashing it against the table. Nothing worked. Nothing worked. So he said, okay, darling, I'm sorry, but it doesn't work. They put it in the drawer in the bedroom. And then the wedding day came, and they exchanged the vows outside the house with their family and friends. And then the bride said, the wife said to the husband, she said, I need to tell you something. And they entered the house, and suddenly they heard music playing. And they went all around the house trying to find out what is the source of the music, where is it coming from? And then they entered the bedroom, and they found the source of the music. It was the old radio playing a beautiful love song. And that's the story. And so I think it's very beautiful. I think it's very beautiful. I think many of us have such experiences in life. Oftentimes we try to run away from this. We try to rationalize. We try to say, oh, it was a coincidence. Or, as one of the commenters to this article on Scientific American said, why not take the radio to a repair technician for diagnosis? Maybe it was a change of ambient temperature, humidity. It's a very good test, I think. When you face an experience like this, when you hear someone tell you a story like this, do you feel happy for these people that they experienced that, which I would like to call love of the universe? Do you share that love with them? Or do you go and look for a repair technician? What does it tell us about today's world? That many of us are more likely to look for a repair technician, for an electrician, to fix the problem, to explain things, to run away from the unknown, unexplored, mysterious, mystical. We talk about science, and I am the one to uphold the science here. I'm a mathematician, which is, the queen of sciences. But I'm wondering, what is it that makes us run away from these experiences under the cover of science? What is it that makes us to believe in science? Kind of almost irrationally believe in something which we perceive as rational. And is our blind belief in science so warranted? You may have heard about the double slit experiment, one of the landmark experiments of quantum physics. It's really absolutely fascinating. So you are shooting electrons through this wall, which has two slits, okay? And you expect them to behave as if they were little pellets that you shoot from a pellet gun. And yet, the picture that you observe on the screen is totally different. Instead of having just two lumps, which you would see if the particles were going through one of the slits or the other, you see the pattern of interference, as if two waves are, have sort of ripples, a complex picture of refraction and interference on the surface of a lake. That's what's happening in this world. That's what science tells us. An electron is like a wave. It is not in this experiment here or there. It is in both places at the same time. Now, I personally think this is a lot spookier than an old radio suddenly playing a love song of the grandfather. I think this is a lot spookier. And in fact, Einstein used that word spooky in German when he proposed, together with two other physicists, Rosen and Podolsky, what is now called the Einstein-Podolsky-Rosen experiment. And he said that quantum mechanics predicts that you can actually have some kind of exchange of information between particles at a very large distance. And he said that surely is impossible. That would be so spooky. And it sure sounds impossible. And yet, many years later, physicists were able to set up an experiment and see and show that that's exactly what happens in our world. There are so many things in science that we don't understand. We try to pretend that we do. But a well-kept secret, and I'm telling you this as a scientist, as a mathematician, I hope it doesn't leave this room, is that we don't know. We do not have, 80 years later, depends how you want to count it, 90 years later, we still do not have a satisfactory explanation of quantum phenomena. The best thing we have is the so-called Copenhagen interpretation of Niels Bohr and others, which basically says, at some point, science breaks down. We just have to accept something. We just have to accept it without understanding. Niels Bohr was a very clever guy. He understood that you should not expect everything to be explainable, surely at this moment, using the language that we have, using the capacity that we have today. There might be some mysterious things which we don't understand. There is a difference between a model and reality. There is a difference between a menu and the actual meal. There is a difference between a map and a territory. A model can give you one way to look at the object, but there could be another way. You can see this side of the moon. Tonight, there is a full moon, and I encourage all of you to do that, to look at the moon. You can see this side of the moon, but you may not be able to see the other one, or vice versa. So, I think that we tend to kind of blindly accept this without really, and kind of like expect the scientists to know. But well, I am a scientist, and I'm telling you, we don't know. And that's the beauty of it. That is the beauty of science, because that's what science tells us, that we should keep an open mind, and we should not believe blindly. We should accept the possibility that the language with which we operate today, that the tools of cognition that we have today are not going to give us a theory of the world, a full and complete description of the world. And actually, to be honest with you, I'm glad. I'm not sure, maybe there is a theory, but I would have personally be more glad that if there isn't. Isn't it more fun to live in a world which is not so easily explained? Isn't it fun to live in a world where I know that not even in the year 2045, as some of us have predicted, the singularity will happen, not even in the year 2055 we will have an ultimate theory of everything. Isn't it wonderful to know that something will be left for our children and grandchildren to explore? A mathematician showing a poem, so that's got to be a little unsettling, but this one of my favorite poets, E. Cummings. I didn't put the whole poem, but I love this last two lines. Life is not a paragraph, and death, I think, is no parenthesis. I think it's our blind belief in everything being explainable by science is what leads us to spend so much time discussing discussing life extension, how to extend our lives, which is very important. I want to live long as much as the next guy. But why do we not spend as much time to discuss what it means to be alive, what it means to be human? Because life, I believe, is not a paragraph, and death, I think, is no parenthesis, as poets said. And I think it's very instructive to look at what happened in the past. Actually, I just read this article in the New York Times on Sunday in the Stone section. It was an interview with a philosopher, Daniel Garber, who's a philosopher, professor of philosophy at Princeton. And he said something very interesting, that in the 17th century, the greatest minds were actually believers. They believed in God. People like Bacon and Descartes and Boyle and Pascal and Newton. Were they misguided? Did they miss something? Should we look at them condescendingly and say, oh my gosh, they were missing crucial information? They were very smart, but somehow they couldn't quite figure it out. Or should we look at it as an example of how we may take a certain thing for granted and not question it? Should we not take this as an indication, as a motivation to ask ourselves, what are the things today? What are the things today that we take for granted and we shouldn't take for granted? And he says, look, it's very interesting what's happening, because today, in that day and age, atheism was considered contrary to evident reason. And since then, science and religion have exchanged places. Now it's the other way around, right? Now there is a widespread belief in science. But as I said, quantum spookiness to me is a lot more mysterious than many of the things that we also encounter in our everyday lives, if we keep our eyes open, for which we don't immediately have an explanation. This is not to say that we should not be informed by the data, because, as I just told you, an electron is kind of crazy. An electron is crazy. An electron is both here and here. And, it's very different from, I wish I had a coin. I don't have a coin, but, okay, maybe I have this, I have this thing. So I can put it in one of my hands. And where is it? Okay, so you don't know where, but it is somewhere. It is here, actually, right? So let's not confuse that we don't know is here or here, but it is actually in one place, at one place only. An electron here in this experiment, and I want to emphasize it one more time, is both of these places. That's the only explanation of this interference pattern. Okay? And if an electron is crazy like this, do you know how many electrons there are in the human body? Well, I don't either. And that's not the point. I was actually tempted to go on and Google it and find out, and then tell you and impress you by saying it's this many zillion, gazillion, billions. But that would be obscuring the point. Yes, we realize there are many. Does it really matter how many? Does the actual number matter? Does it matter if I tell you how many stars there are in the observed universe? Does it matter if I tell you how far the moon is? E. Cummings said, nobody knows who the moon is. Will this data help me to find out who she is? That is a question for me. And nothing wrong with data. I love data. I am Mr. Data myself. But to think that data is all there is a dangerous mistake. It's a dangerous mistake. Because when I listen to a piece of music, yes, it is, one could say, it's a collection of notes, frequencies, zeros and ones. But is it these zeros and ones that make me cry, or laugh, or make me feel deep emotions? Or is it something else? Is a human a sequence of zeros and ones? Is it just bits and pieces, or is something whole is more important? These are the kind of questions that I was wondering about when I was writing my book. I just wanted to show you. Not because I want you to buy it. Although it couldn't be easier to do that these days, you know. Come on, it's just one click on Amazon. How hard is that? But you don't have to do it. That's perfectly fine. But the book is important because I also want to tell you my personal story. Which is kind of, the book is called Love and Math. And people were asking me, the book was published a year ago, okay? And so I was interviewed, I've given public speeches, I talked about this. And people would always ask, why do you call it Love and Math? Why do you call it Love and Math? And I didn't know. I would always give a smart-ass answer. I would say, for example, one answer is, well, everybody thinks that they hate math, but everybody loves love. So I want to put some love into math. Not a bad answer. Or I would say math is kind of like love. It's simple at first, but then it could get awfully complicated. But I actually didn't know the answer. And now I know, and I want to share it with you. I realized recently that actually I called it like this because, in fact, this was my love letter. This book was a love letter that I wrote to a subject which most people think is stale and boring and terrified of. But for me, I was in love with mathematics, and mathematics actually, this love for mathematics in many ways saved me. I tell the story in my book, and I don't want to get too much into this, but when I was 16 years old, I was failed at an examination at Moscow University because my name is Jewish, my father is Jewish, and there was anti-Semitic policy, discriminatory policy in the Soviet Union at that time, 1984, by the way, which is, of course, a great novel by Orwell.
I was when time was
That's right.
I didn't get a job because of this.
He was very prescient, Mr. Orwell. So I was failed ruthlessly. And they didn't tell me that we fail you because you're Jewish. No, they told me there was a carefully cultivated art of giving you problems, which, quite interestingly, they called them problems coffins, coffin problems. So it's like they wanted to put me in a coffin, me and other kids. And they did. But the reason I survived, the reason I did not die in that coffin, was because, now I realize, was my love for mathematics. Mathematics, I knew mathematics was a world which was outside of the world, Soviet Union, circa 1984. Mathematics is a world in which bigotry and prejudice and hatred of the other has no place. And it is my ability to connect to that world, my knowing that world, that helped me to survive. And this book was kind of my book is kind of a love letter to mathematics, and maybe a love letter to others, because I wanted everyone to read it and to hear it, to feel this love. Because when you have love, when you experience love, you want to share it. And this is very interesting because I've been thinking about this, because mathematics is really about rigor and logic. So how can you possibly use the word love when you talk about it? It's supposed to be about zeros and ones. What am I here telling you that human is not a sequence of zeros and ones? But there is a trick, there is a catch. And the point is that, yes, it is the most rigorous subject. It's the most logical subject. But it itself lives outside of logic, outside of space and time, in a kind of Platonic reality of its own. The most cerebral and the most logical thing is outside. And connecting to it at the deepest level is what enabled me to realize that there is more. There is more. Now, when I say the word mathematics, it's kind of very difficult to have this conversation because most of us get exposed just to the kind of math that we learn at school. And I like to use this analogy. Think of an art class in which they teach you only how to paint fences and walls. And they tell you, this is all there is to art. All there is to art. They never show you Van Gogh and Picasso and Leonardo da Vinci. They never tell you that there exist museums where you can go and experience those paintings. What would you think of art if you were so, I'm sorry to use that word, indoctrinated? Because that's what it is. Of course you'll hate it. Who would want to spend, go to class day after day and paint fences and walls? So mathematics, in fact, is much bigger and much more beautiful and much more sophisticated. The real math, the kind of math that me and my colleagues do, professional mathematicians, but we don't talk about it. We don't talk about it. It's a much bigger and more fascinating subject than we have been led to believe. What it is a hidden parallel universe, full of elegance and beauty, and intricately intertwined with our world. Now, just want to, of course, the next question is, what is it? What is it? Show it to us. Well, read my book, first of all. But not only my book, but there are many other great books that you can read. Documentary films, movies, videos, etc. But just to give you an idea, one of the things I talk about in my book, I talk about different continents of math. Imagine that. Mathematics is not just this one homogeneous field. It has different continents, it has different parts, which kind of don't talk to each other or speak different languages. Like number theory, the study of numbers and equations. Things like, first you have whole numbers, 1, 2, 3, 4, then you have fractions. Then you discover square root of 2, which is not a fraction. And Pythagoras, for once, did not believe it was a real number that we should accept in a family of numbers. It was irrational. Not because it was acting irrationally, but it was not a ratio. There is harmonic analysis, which we experience when we listen to music. In fact, if you try to deconstruct the sound, I think there's more to a beautiful symphony. But if you just look at the sound and frequencies, what you're doing is harmonic analysis, decomposing the sound of the entire symphony orchestra into different notes of different instruments. There is geometry, the study of shapes like this, a sphere, a torus. That's Homer Simpson's favorite one. And this is one of my pet peeves is to talk about geometry and to say that at school we only study Euclidean geometry. Nothing wrong with that. Euclid wrote his Elements 2,300 years ago, 300 BC. Homer lived approximately at the same time. Why is it that in our math classes we stop geometry at Euclidean geometry, which was 2,300 years ago? Why is it in our literature classes we don't do that? Why do we read T.S. Eliot and Melville and Salinger and maybe even E. Cummings? Why can't we do that in our math classes? And that's the first example. These are two examples of non-Euclidean geometry. Just as real as a plane, as a floor of this room, which would be a Euclidean one. Oh look, and this is the surface of the Earth. Why don't we study that? Why don't we tell our kids about that? That's a subject for another conversation. I talk about the Langlands program. This is Robert Langlands at his office in Institute for Advanced Study, who found connections and bridges between these different fields. That's what real mathematics is about. And when you do mathematics, when you connect to mathematics at this level, at this deep level, you realize that not all of it comes from physical reality. This is something that even a lot of mathematicians don't think much about. But it is true. Most of the things we do not manifest themselves in any obvious way in the world around us. Various numerical systems, various infinite dimensional spaces. Where are they? They are nowhere to be found around us. And yet mathematicians were developing these ideas, developing these theories. And these theories are necessary and timeless and unchanging. Pythagoras came up with his theorem, Pythagoras' theorem, which we all studied at school, which actually is a great result, 2,500 years ago. Now, when I say that, people often raise their hands and say, no, actually there was someone else in China or in Babylon who discovered the same thing. And I say, thank you. That's exactly my point. If Pythagoras had not discovered it, someone else would have discovered it. Our children discover it in the classrooms every day. Why is it that we discover the same mathematics? The same, one and the same mathematics. This is something which we are not supposed to talk about. Just like the radio. But most mathematicians, when pressed hard enough, will admit that they are secretly Platonists. They do believe that some mathematical ideas exist outside of physical reality, outside of consciousness. And that is the beauty of it. When you realize that, when you realize that there is this amazing world of mathematics, which nobody told us about, this, by the way, Kurt Gödel, one of the great mathematicians, Albert Einstein, who was his colleague at the Institute for Advanced Study, used to say that the only reason I go to the institute is to walk back home with Gödel. He's the smartest man I know. Kurt Gödel said mathematical concepts form an objective reality of their own, which we cannot create or change, but only perceive and describe. Now, my point is, when you realize that mathematics is like that the world of mathematics is something very special, there are two possibilities. One is to say, aha, that means that everything is mathematics. Mathematics controls everything. And there are people who say that. And they kind of rejoice in this. Wow, that's great. So everything is, a human is a sequence of zeros and ones. We are in a kind of computer simulation. And so maybe the next idea is, why don't we create robots and upload our minds onto those robots and reunite with those machines that have created us? A very dangerous idea. And that's one possibility. And another possibility is to say, okay, mathematics is out there. What else is out there? Well, there is love. There is love and math. You realize this way that they both exist. Neither can be replaced by the other. And how do you realize? Well, if you have fallen in love. That's one way to do it. Or you can call Mr. Gödel and his beautiful incompleteness theorem. If you don't accept the argument that you have actually experienced love and it was not reading a programmer's code, if you don't accept that argument, ask Mr. Gödel, who explained to us that no sophisticated enough formal system can prove every true statement within it. How do you expect the world to be otherwise?
Edward, we need to...
So to wrap this up, I want to leave you with this quote. Isaac Newton said that to himself, he was just like a boy playing on the seashore and diverting himself and now and then finding a smoother pebble or a prettier shell than ordinary, whilst the great ocean of truth lay all undiscovered before me. And so Allison talked about children and psychology of children. And I think it's very important that mathematics is something where we cannot lie. And so the way to connect to mathematics is kind of connecting to our inner child and being true to ourselves. And maybe this is the answer, that connecting to ourselves and loving ourselves, we will discover both mathematics and love. So, as I say in my book, my dream is that one day we will all awaken to this hidden reality. Perhaps then we can put our differences aside and focus on the profound truth that unite us. And then we will be like children playing on the seashore. Thank you.